let's skip this one. And the reason why is because if people want to put in a valiant effort and do a lot of work, this is probably the least documented lab, is what I want to talk about tonight. The reason why that is because this lab uses some classes. And so I was trying to introduce classes before this lab because I present code that's in a class. And a class is C++. And a class is just an organizational tool for putting functions that are related together in a single location, functions and variables. So in this class, so a class is defined by just saying class, you give it a name, open squiggly brace, and then you're going to have a list of functions and variables. So here's a function, here's a variable, and then here's something new that says public. And so in a class, by default, things at the very beginning are declared as private, and after you put the word public, all this stuff is public. And what I'm going to say about this is going to sound very weird, or at least it sounded very weird to me when I first was learning classes, and that is that the idea between public and private functions. And the difference between them is when you have a class, any function that's private, the user of the class cannot see that function and cannot use that as function. Whereas public functions and public variables, the user of the class can see those. And the reason this sounds very weird is because if you're sitting there trying to learn how to use classes, and you're writing the class, and you're using the class, you're thinking, why would I ever want to make something private? I'm the person writing it. Why would I want to keep myself from using a function that I'm writing? I want to use those functions, right? So that's the weird thing about this public and private. But it actually has a really useful purpose. And the purpose is you can create functions that if somebody else was using your class, or even if you are using your class, a service function inside the class that these private functions may call, and it may be perfectly okay, but the user of the class, even if it's yourself, you may never want to call this function because you could break something or cause some desirable behavior. And that's the whole idea between public and private. Is it's a way to certain functions from being visible to the user of the class. And the user may be you, it may be somebody else. And when I write classes for myself that I use by myself, I often create and use private variables and functions just for that purpose. So it's kind of a hard concept to grasp without seeing a lot of use. Here, there is one variable that's a private variable that represents the chip select for the chip we're going to use. And so the idea of this chip select is being private would be when you first create the class, you say, I want this chip select to be on pin 9. And blow it up real big just to make sure you can. So here's the class. It's an LCD class. And these are the private functions. Or this is the private function. It's called LCD out. This is what actually sends the information to the LCD. And then there's a private variable called LCD 301C31TR. That's probably the part number for the display. Chip select. So this variable in this function, when we create an instance of this class, we define the chip select. So we'd say something like, I want the chip select to be pin 9, right? And so this chip select variable would be 9. And then in this class we say that private variable, so this function is public, and so anybody can access it, but this variable is private. But because it's in the class, this function can see the variable and use and access it, but the user of the class cannot. So the user of the class says, hey, I'm going to pass in a 9, and so this variable is 9, and I assign the value of 9 to this private variable. Okay. Now, once this class has been created and it's up and running, and we've defined our chip select to be pin 9, it would be very bad if your program or something else came along and changed that value from 9 to something else, because 9 is where the pin will be physically tied to. And this is an example of why you would want something to private. Is you want to make sure that the user of the class doesn't inadvertently change that value, and you, being the user of the class, potentially could screw yourself up if you changed it, and so that's why you want the private variable. So let me open the. These are the LCD nodes. And the LCD we're using is kind of like this one right here, segment display. There's graphical displays, and of course color displays, and so these ones. This one down here is called a character display. So this type of LCD that we're using has kind of these 7-segment type features. Or if you look very closely at the display, you can see there's little breaks in the segment, and so this whole piece lights up individually, this whole piece lights up individually, and so on all the way around the display. And these are called 7 segments because if you count them, do 1, 2, 3, 4, 5, 6, 7. And they always call them 7-segment displays, but they usually come with a decimal point that is an 8th segment. There's 2 dots here. My guess is this is a segment, this dot right here is a segment, and then these 2 dots together are 1 segment, even though they look like there's a break between them. Here's 7 more segments, and here's the 1 segment, here's a segment. This minus sign here is probably a segment, and the dot above and below it are probably together a segment that will turn it into a plus. And this thing that says low bat by itself would be its own segment. So although there's a break in the segment, like these 2 dots, it may actually only count as 1 segment. And so if we counted them, there's 1, 2, 3, 7 segments, so there'd be 21, 22, 23, 24 with the decimal points, 25 with the colon, 26 with the minus, 27 with the plus, and 28 with the low bat. So, and if we counted the pins, and they're kind of cut off, there's probably 28 pins, maybe 29. I'm not going to try to count. So, now these other displays, like this graphical display, as far as I can zoom in, they have a single pixel. A single pixel is equivalent to what might be one big pixel over here. I don't know the term. Stands for picture element. These are pixels on this display, and this is a pixel on this display. So if you wanted to represent all of the information, pixels here on these 2 displays, they can either be on or off. That should sound like binary, right? On, off, binary. So this display, because it has 28 pixels or segments, it would need 28 bits, or about 4 bytes, to store all of the information for the display. So only 4 bytes, right? So you represent any possible combination of the display. You can make it say 1, oh, I didn't count these. 28, 20. So it's still less than 4 bytes. So 32 would be 4 bytes. But if you lit up these 2, and then these outside ones, you can make this say 1, 0, 0, 0, right? And some are shut off, right? And so you could turn some on and some off, and all that information required to turn the segments on or off can be stored in 4 bytes of data. It's not a whole lot, 32 bits, right? Now, this display over here, this is a graphical display, and I know from the part number, because I've used these type of displays before, it's 160 pixels by 128. And although this display is bluish in color, that's all it can display. It can display like a light blue or a dark blue, or a white or a blue is what they call it. So when the pixel's on, it looks white, and when it's off, it's blue. So each pixel can only be 2 colors, well, on or off, white or blue. But there's 160 pixels by 128. So 160 across, 128 down. So that, and each one of those, to store the memory for those, 1 bit again too. But it's 160 times 128. And then mark these on. 160 times 128. So this is 20,480 bits for the whole screen, right? And if we divide that by 8, it's 2,560 bytes. This display required 4 bytes. This one requires 2,560, a significant number more of a significant amount of memory more. Okay, now this one, this color display here, it's a 240 by 400 RGB display, and RGB stands for red, green, blue. And it doesn't indicate how many shades of each color. Let's say there was 4 shades of each color, red, green, and blue. So that would mean you have 240 bits wide times 400 bits hot pixels, 240 pixels wide by 400 pixels high, and then times 4 bits for red, times 4 bits for green, and times 4 bits for blue. So this one requires 6 million bits, 6,144 bits, and then we'll divide that by 8. So that's 768,000 bytes. So not quite a megabit, but 768 kilobits. Now this display, requires so much memory that the chips that we're using in this class, some of them have 512K of program space and 128K of RAM. So if you used all of the program space and all of the RAM, you couldn't even store a single image for this display on this processor. Now, what you might be able to do is draw a line. This display may have memory built into it, so you may be able to draw to it and draw lines and higher level shapes to be able to still use it with this type of processor. But you couldn't store the images for this display on the processor. And you could use external memory like an SD card. This display, black and yellow display, and this display, they're a special type of display that are graphical, but they have built-in fonts, so you're only sending ASCII characters to it. So this one might be like a 40 by 4, so maybe 40 characters across and 4 lines down, and then so it would be 40 times 4, it would be 160, and then each character would be an ASCII character, so times 8 bits, so 1K for this whole display. If you actually had to store the individual pixels, it would be quite a bit more. And each little pixel here it's 5 pixels wide by 8 pixels high. So if it did it per pixel, it'd be 5 times 8 times 40 wide times 4 high would be 6,400 bits or 800 bytes. But just store ASCII, 40 times 4 times 8. Divided by 8, actually, that's the number of bits. It'd be 160 bytes, right? So if we stored all the individual pixels, it'd be 1,000 something bytes. But if we just store the ASCII characters, it'd be 160 bytes. They allow us to put a lot of information up without having to deal with the complexities of the display. So the display we're using looks a lot like this, where we have this. It doesn't look a lot like this. It's exactly like this, right? We have digit 1, 2, and 3. There's 3 7 segments, a decimal point 1 and a decimal point 2, and the segments are labeled A, B, C, D, E, F, and G in the center. And each display segment is identical to the ABC pattern is the same. And if you get a 7-segment LED, the